Hello everyone, I'm Steven and you're watching Steven Loves Science. And today I'm putting on my chemistry boots for y'all so we can talk a little bit about how to find the density of a gas. So thus far in our chemistry videos, we've talked about the Pivnert equation. PV equals nRT allows us to find the pressure, volume, number of moles, and temperature of a gas. But it does not allow us to find the density. But what we can do with Pivnert is modify it a little bit to get this equation, which does allow us to find the density of a gas, and we're going to talk about how we derive this equation at the end of the video. So, density equals pressure times molar mass divided by universal gas constant times temperature. So, very simple plug and chug formula, so let's get started with an example problem, shall we? Okay, this problem asks us to calculate the density of carbon dioxide in grams per liter at 752.4 millimeters of mercury and at 55 degrees centigrade. So, let's get started. To solve for density, we must know the pressure, we must know the temperature, and we must know the molar mass. And the R constant is given to us. All right, so the pressure given to us is 752.4 millimeters of mercury. Now, that is a very inappropriate unit for dealing with gas equations. Millimeters of mercury, very naughty. What we want to do is convert that to atmospheres. So, how do we convert that to atmospheres? Some very quick and easy dimensional analysis. So, 752.4 millimeters of mercury times the conversion factor, which is 1 atm for every 760 millimeters of mercury. And lo and behold, that gives us an answer of 0.990 atmospheres. So that is our pressure. That is a very acceptable pressure unit, a very Amish pressure unit, not inappropriate at all. 0.990. A nice decimal point there. All right, now temperature. All right, the temperature is given to us as 55 degrees centigrade. Once again, a very inappropriate unit. These units are troubled teens right now. The textbook writers are troubled teens, are acting out in wildly inappropriate ways, giving us 55 degrees centigrade. So how do we convert 55 degrees centigrade to the desired unit, which is Kelvin? So it's very easy conversion. 55 degrees centigrade, 55 plus 273 equals 328 Kelvin. We don't say degrees Kelvin, we just say Kelvin. So temperature is 328. Now, lastly, we must find the molar mass, which can be found simply by adding the atomic weight of carbon plus 2 times the atomic weight of oxygen. And that gives us 44.01. Is the molar mass is 44.01 grams per mole. All right, we now have all the information we need to start to plug and chug. So let's get started, shall we? Alrighty, so I've moved this around a bit so we can begin the plug and chug process. Okay, so we're going to plug in our pressure, which is 0.990 atmospheres. I'm going to plug in our molar mass, which is 44.01 grams per mole. I'm going to plug in our proportion universal gas constant, which is, I don't know, the units for that are really, really bad units. 21 liter times atmospheres over Kelvin moles. And lastly, I'm going to plug in our temperature, which is 328 Kelvin. Okay, so now we can start canceling. The first thing I'm going to look at, can we cancel anything up top here? No. Can we cancel anything up top here? No. So now we're going to start canceling within the problem. We can cancel Kelvin, Kelvin, can cancel atmosphere. We can cancel moles there. And that's about it. So what are we left with? We're left with grams, and we're left with liters. So let's go ahead and plug these numbers into our calculator. All right, and what we get is 1.62 grams per liter, which is what the problem was asking us for. And that is our density. All right, très bien. We found the density of our gas. That was done using our very easy provided for you density formula. But now let's figure out how we can derive that formula from the PV equals nRT equation. So you'll never have to memorize this if you know how to derive it. So let's get started. Alrighty, so now we're ready to learn how to derive the density formula from PV equals nRT as promised. So really, what is density? Density is mass over volume. But you're probably thinking right now, Stephen, there is no space for mass in PV equals nRT, but it's hiding, and I'll show it to you. So to get started, we're going to have to first start by rearranging this formula. So we get N over V equals P over RT. Okay, so what is N? This is our question mark here. What is N? N is number of moles, but how do you find number of moles? Time to go in the Wayback Machine, y'all. Number of moles is mass over molar mass. So that's where that mass comes from. Number of moles is mass over molar mass. So we can now rearrange this, N equals mass over molar mass. We can rearrange step 3. All right. So mass over molar mass over V equals P over RT. What that really is M over molar mass times volume equals P over RT. Further arranging this, we get M over V equals PM over RT. And there you have it. Thank you very much for watching this episode of Stephen Loves Science.